All right, so what is factorial, right? We kind of mentioned that you kind of got exposure to it in your lab exercises. So the factorial function, right, is this, it looks like this, right? N factorial. What does that mean? Well, 5 something, a number like 5 factorial, that is equal to 5 times 4 times 3 times 2 times 1. Okay. Now, we're going to first just solve this iteratively. In other words, and when I say iteratively, I mean the way we normally solve things, right? We are going to go through and make sure that we can, just write it. Public static void, int factorial int n. And so this will take in n, and we're going to generate n factorial. So I'm going to just write down some known values here. 1 factorial, 0 factorial for some odd reason, which I'm sure if you ask a mathematician, they'll tell you it's 1. 1 factorial is 1. 2 factorial is 1 times 2, so that's 2. 3 factorial is 3 times that, so we get 6. Right, 4 factorial is 24. And 5 factorial is 5 times that, so 120. All right, and that's just some way we can check our and then we just have that to check our answers. So first things first, there's no such thing as negative factorial, so let's go ahead and say, hey, if but we'll go ahead and say, hey, if we get n, so if n is less than or equal to 0, we'll just go ahead and return 1, even though that might not be mathematically correct. So, return 1. What we'll do over here is that we'll return that. If n is instead less than 0, we'll return maybe -1 until somebody tells me something different. Okay. Right, and then for int I is equal to 0, I is, right, so we've got this n factorial. So if we've got n factorial, we want to generate 1 times 2 times 3 times 4 times 5 times 6 all the way up to n. So we've got this, so we'll want to do a running product. About as easy as it gets. 1 for I, so int I is equal to 1, I is less than or equal to n. So all the numbers from 1 up to and including n, we are going to do product times equals I. So we're going to multiply product by 1, then by 2, then by 3, then by 4, then by 5. Return n. Looks a bit messy, but not n. We're going to return product. Looks a bit messy, but nothing more messy than we've ever done before, right? So factorial 4, we run it. Nothing too surprising is going to happen. Except, your professor forgetting that he should probably print stuff out. All right, so we run it again. 24, pass in 5. Oh. And don't delete something this time. Pass in 5, and we get 120. So let's go ahead and pass in 6. So 6 times that amount. So 6 times 120 should be 720, I think, if I'm doing my math correctly. Yep. And so then 7 times that would be 7 factorial. And so now let's go ahead and plug in like maybe 20. And something fun is going to happen here. We get we get a overflow, right? The number is too big to be stored in an integer. Factorials grow really, really, really quickly. They're actually huge. So instead of returning an int, I'm going to go ahead and return a long and switch this product into a long, because if we want it to be able to return big numbers, we have to be able to hold something that returns a big number, right? That's 20 factorial. Factorials grow immensely quickly, which is why you never want to really see them in in an algorithm. Okay, so all right. So how does it how does recursion work then? All right. So I'm going to go ahead and start that in the next video.